Hello friends, so our today's question is game of life. What is basically given in this question, we are given a board made up of m cross n grid of cell where each cell has initial state. Okay, so either a cell is live or it is dead. So live cell is represented by 1 and dead cell is represented by 0. Okay, and each cell interact with 8 neighbor. Okay, so like in this case, this is the cell, so it interacts with 8 of its neighbor horizontally, vertically and diagonally. Okay, and then okay, so we have to use these following four rules and we have to determine what will be the next stage of this board. Okay, so okay, so what are the basic what are the four rules? Let's go through them one by one. Okay, so any live cell with fewer than two live neighbor died as if caused by underpopulation. Okay, so what is given, like let's consider this scenario. So this is the live cell. If it is surrounded by these 8 cells, okay, let's consider these cells. Okay, it is surrounded by these cells. So if surrounding cells have two lives less than two live cells, then this will be dead. Okay, so if we consider this, here we are having four dead cell and one live cell, so which is less than two. Okay, so this will be considered as dead. So if we see the next stage of this, so here the cell has already died. Okay, now let's consider the second rule. Any live cell with two or three live neighbors live for next generation. Okay, so if any cell, let's consider this cell. Okay, let's consider this cell. Now its surrounding cell will be this. Okay, so what is given? If any cell surrounding neighbors contain two or three. Okay, with two and three live neighbors. Okay, two or three live neighbors, then this live cell will persist for next generation. Okay, so if we count, so if it contain one, two, three live cells, so yes, so in the next stage also this cell is live. Okay, now let's go to the third rule. Any live cell with more than three live neighbor died of overpopulation. Okay, now let's consider this scenario. Okay, let's say, okay, overpopulation. Okay, so what is basically given in this scenario, like this, we are having one, and for neighbor cell, let's consider this one, 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 zero, zero. So this is our surrounding for this. We are considering this cell, and in its surrounding the live cells are greater than 3. So in this scenario, its next stage, it will die because of the overpopulation. Okay, so what will be the next stage for current scenario? 0, 0, 1, 1, 1, 1. So this cell is died in the next generation because of overpopulation. So this is given in the third rule. Now fourth rule, any dead cell with exactly 3 live neighbor becomes live cell as if reproduction. Okay, so if we consider like this is a dead cell. Okay, but what is this rule said? If its surrounding neighbors contain exactly three live cells, which is this scenario, which contain three live cells, so it also become live. So in the next stage, this also become a live cell. Okay, so basically these are the four rules which are given to us. Okay, now what next is given in this question is the next stage is created by applying the above rule simultaneously. Okay, so we are moving from this stage to this stage by applying all these rules here. Okay, simultaneously to every cell in the current stage. Okay, when birth and death occur simultaneously. Okay, so we are given this stage, we are given the initial stage, we have to return the next stage. Okay, by applying those four rules to each and every cell of this n m cross n matrix. Okay, so basically we have understood the question. Okay, now what follow up, what is given in the follow up? Okay, so could you solve it in place? Like, okay, we can use extra space. Okay, we will discuss that approach in the solution, but we have to try to solve this it in place. Okay, we don't have to use any new space for the solution of this. Okay, remember the okay, so now let's say we have to update the board simultaneously. We don't have to use those previous value, like, okay, in this case, let's say in this case like this become 0. Okay, So we don't have to use now new value of this to compute the element for this. If we are computing this, so its neighbor, one neighbor would be this element also, okay, this element also. But we don't have to use its new value, we have to use its previous value to find or to compute current stage for the current cell. Okay, we are calculating for this cell, then for its neighbor we don't have to use those neighbors previous new value, we have to use those neighbors previous value. Okay, so this is only given. You cannot update some cell first and then use their updated value to update other cell. Okay, okay, so this is basically given in the follow-up. Now, oh, okay, and what else is given? Like in this question we are considering it to infinite words, so we have to take care of these edge cases, like because for this we don't have all the 8 neighbors, we only have 3 neighbors. Okay, so we have to take care of these edge cases scenario. Okay, so basically, okay, I think we have understood the question pretty well. Now let's look for its solution approach. So first of all we will try to solve it in first approach we will use the space complexity of m cross and we will try to solve it in that approach. Okay, so let's say we have created, okay, we have created a same space matrix of same size m cross n, and then what we can do, okay, we have created an empty space. Okay, now what we can iterate to this matrix through row and column, and what we can do for each cell we can find out its neighbor and we can determine whether it will be live or it will be dead in the next stage, and we can keep the value here. Okay, so now let's dry run this. Let's dry run this. Okay, so for the first value let's calculate 0 1 0. So for its neighbor it's only one live cell. Okay, we don't have 3 live cells, so it will not be alive, so it will be 0 only. Okay, now let's go for this one. So it's contain only one live cell. So as we have seen in the rule, for current live cell to be live in the next stage also, it should be have 2 or 3 live cells in its neighbor, so it will be dead. Okay, now for the third okay, so for the third cell, if we consider its neighbor, so it contains 2 1, so for it to be alive it required 3 life cells in its neighbor, so it will be 0 only. Okay, now for this it contains 3 life cells, so it will be it contains 3 life cells, so 0 become 1. Okay, because of the reproduction as stated in this fourth rule. Okay, for the next cell 0 it contain more than 3 cells, so it will be 0 only. Okay, for this one it contains 3 cells, so it will be alive only. Okay, for this one, so for its neighbor it's contain only 1 cell, so it will be dead. Okay, for this one it contains two live cells, so for current cell to be live in the next cell it should have 2 or 3 live cell in its neighbor, so it will be 1 only. Okay, for this one it contain 2 live cells, so it will again be alive for the next stage. For the 0, if we consider this, so it contains 2, so it will be 0 only. For this live cell it contains 3. Okay, so it will be alive because of reproduction, fourth rule. And for this 0, it contains only 2, so it will be 0. Okay, so this is our resultant array, resultant matrix. So using extra space it is very simple to solve this. You just need to calculate the number of live cells for any particular cells, and then according to the 4 rules which we have defined, which are given in the question, we have to compute its current value. Okay, but we don't have to use this extra space, and we have to try using the current space in place solution. Okay, so now let's look for the approach, second approach, where we will use constant space, that is capital O of 1. Okay, so now basically what is given in this question, uh, we have to count number of live cells around any particular cells. Like if we are talking about this cell, okay, so we have to consider or we have to count number of live cells around this. Okay, because this is what its neighbor elements are. Okay, so in that we have 3 live cells, 4 live cells. Okay, and this is our current cell. Okay, so we have to count number of live cells okay, around any particular neighbor. So that is the first thing that we need to do. Okay, now on the basis of that, if a particular cell, okay, let's say this is the particular cell which has become 0. Okay, this is the particular cells which has become 0. Okay, because of underpopulation, because it only has one life cell in its neighbor. Okay, so because of underpopulation this cell died in the next stage. But we for computing the value for this, or for computing the current state of this, we have to take the previous value. Like we in the current in the current stage is become 0, but we don't have to use this 0, we have to use its previous value, that is 1. So what we can do, we can change this value. Okay, when, okay, we have to consider two states. When let's say when cell become alive and when cell become dead. Okay, so mainly we have to take care of these two situations, when cell becomes alive and when cell become dead. Because in other cases, when cell is alive because of its population in range of 2 and 3, and it is dead because of the because it is already dead and its neighbor does not contain value to make it alive, to make him alive. Okay, so these two cell will be take care by counting the number of live cells around this. Okay, but we have to take care of these two stages, when cell become alive and when cell become dead. Okay, so now what we can do here is, for computing each time, like when a cell become dead, when can we do it like this? We can make that cell as -1 instead of 1. We can make that cell as -1. Okay, and whenever we are computing the neighbors of this, we can take the absolute value of 1, absolute value of current cell. Okay, this we can do. So what we can do, like when we will compute for this, now we will take absolute value of this. Let's say it become died and we have made its value to -1. Now for calculating this cell, what we will do, we will compute these 8 neighbors. So we are taking absolute value, so we can take the absolute value, so it will be 1 only. Okay, because two live cells are represented by 1. Okay, so this we can do. So in this way we can calculate when cell become dead. Okay, so this is the first thing we have taken care of. Now when cell become alive. Okay, so in this case, when cell becomes alive, what basically we are doing, okay, we have converted this into -1. Now if this cell become alive, okay, this cell become alive, but what we will do, we will not take this one value for consideration, because we have to use the value from its previous stage. If we are computing the value for this current stage, for this we have to use the value of its neighbor from its previous stage, not from the current stage. Like this 0 become 1, we don't have to use this 1, we have to use this 0 only. Okay, so what, while computing the live cells, what we are considering 1. So we can, when cell become alive, we can make this value as any other than 1, 0 and -1. What we can do, we can make this cell value as any, like we can make this cell value as 2. Okay, so when so what we will do, okay, so let's see, like do some modification here only. Okay, now let's consider, okay, 0, this is 0, 0 it will be. Now 1, it becomes 0. Okay, because it dead, so what we will do, we will make it -1. Okay, and then this is 0, this is this, okay, this becomes a live cell because of overpopulation, because of 2 or 3 live neighbors. So let's say we've done it to 2, we have changed its value to 2. Okay, let's take a darker one, little bit zoom. Okay, so this is -1, it become -1, this become 2. Okay, now 0, this is 1 only, this dies because of overpopulation, so we will take it as -1. Okay, this is 1, 1, this becomes live because of, so it becomes 2. So when we have done with this now, so what we can do, in the last we can iterate over this matrix, and where we will find -1, we will update that value to 0, and where we will find 2 or any other value, we will update that value to 1, so we will get the resultant array. Okay, so this we can do. We have to take care of these 2 points, when cell becomes alive, when cell becomes dead. Okay, we have taken care while replacing a dead cell with 1 to -1 and 0 to 2 when it's become alive, because we are when we will compute na total number of live cells, we will take absolute value of current cell, and what we will check if its value is equals to 1. Okay, so if we have done if we have computed this to be 2, so when we will compute for this now, so we will take only 1. We will check for the equality that is equals to 1. So this -1 will be considered as 1, this one will be considered will be take care, these will be taken care, but this 2 will not be taken care because we have put the condition of equality. Okay, so this 2 will not be considered, so it will be treated as 0 only. So if it is 0 or if it is 2, so we will get total number of live cell as 3 to 5 for this current element. Okay, so in this way we will build our solution. Okay, so I think we have understood the approach. Now let's jump to the solution. Okay, so first of all, let's say int row is equals to board dot size, int column is equals to board 0 dot size. So we have computed the value of board and rows and columns. Now for, let's say for, so what we will do here, for what we will do, int I is equals to 0, I is less than row, we will I plus plus, then for int j is equals to 0, j is less than column j plus plus. Okay, so what we are doing now, we have to, first of all, we have to count the number of live cells around this cell. Okay, live neighbor cells. Okay, so what we will do, we will take it as count is equals to we will make a function for that, count count live live ngh urs live neighbor, and what we will pass the current. First of all, we will pass the board, then we will pass the I comma j value, then the number of rows and columns. Okay, so what we will do, we will make this function. Okay, so okay, let's first of all make this function on the board to count the live cells. Okay, so what it will return, it will return an integer value, int let's count neighbors, then we will have a vector of vector vect or vector of vect or vector of int board, then int row, then int column, then int row, and then int column. Okay, so basically let's say int count is equals to 0. So we have to take care of the edge cases where the cells are of boundary, like end row, starting row, end row, starting column, end column. Okay, so what we will do, first of all, we will iterate, we will check internally for int I is equals to 0. Okay, so what basically, so okay, like this is the cell, so we have to calculate till it's like this is column value for column, so column -1, column +1, and in the same way for row, we have to row -1 and row +1. Okay, because it contain these 8 neighbors. Okay, it will be r -1 till I is less than equals to r +1 I plus plus, in the same way for int c, int j is equals to c -1, j is less than equals to c plus 1. Okay, then j plus plus. Now what we will do, we will check if, so if we are calculating live cells for around live neighbors around the cell, we don't have to consider this. Okay, this we have to exclude because we are calculating neighbor. Okay, so what we will do, we will first of all check if I is not equal, if I is equals to R and C is equals to J, C is equals to J. Okay, if this is a cell, or I is less than 0, or J is less than 0, or I is greater than equals to row, or J is greater than equals to column. In this case, what we will do, we will continue, we will escape the iteration, and in else, if, what we will do, we will check. I have, as we told, like we are making, if any cell is dead, we are making it as -1. Okay, so we will take the absolute value so that it won't affect the calculation for other cells, to for calculating the live cells in its neighbor. Okay, so we will do absolute value. So absolute value of BOARD board, I comma J, absolute value is equals to 1. Okay, so what we will do, we will implement the count plus, and at the end we will return count. Ret will return COU and the count. Okay, so this function, so here we will get the value of count. Now on the basis of this count value, we have to just implement or just take care of those 4 rules. Okay, so what we will do, we will check first if, okay, so we will check if count is less than 2, or count is greater than 3. Okay, so in this case, end current cell is BOARD board I comma J is equals to 1. Like current cell is 1, and its neighbor count is neighbor count of live cell is less than 2 and greater than 3. In this case, because of overpopulation, it will die. Okay, so what we will do, we will convert into -1. BOARD board of I comma J is equals to -1. Okay, and else if, what we will check, and we have to take care of overpopulation. So if count is equals reproduction. Okay, fourth rule. So if count is equals to 3, and BOARD board of I comma J is equals to 0, then what we will make, we will make it at any value other than -1, 1 and 0. So we will make it at, for now, 2. ARD board of I comma J is equals to 2. Okay, so this we have done, but this we have converted into -1 and 2. So at last, what we will do, we will just map those to 0 and 1. Okay, so for int I is equals to 0, I is less than row I plus plus, then int j is equals to 0, j is less than call j plus plus. Okay, now if BOARD board of I comma j is less than 0, we will make it as BOARD board I comma j is equals to 0, because -1 we have made it to -1, so -1 indicate it is dead. Else if BOARD board of I comma j is equals to 2, what we will do, we will make it as 1, because it is alive. Board of I comma j is equals to 1. Now let's run this and see whether it runs. The first code, yes, it is accepted. Now let's submit. So it is submitted successfully. So okay, So for time complexity it is constant because we have not used any extra space, and for sorry, for space complexity it is constant because we have not used any extra space, and for time complexity it is capital O of m cross n because we are iterating to the whole matrix 1. Okay, so thank you for watching.